Hello, this is for Comp Org Quiz 2. Jumping right into it, partial credit 1 asks for speed up. I calculated this using the equation of old execution time over new execution time. To calculate this, I just made up a variable t, and t is equal to the execution time of MIPS FP. And because MIPS FP is 12 times faster than MIPS nights, 12t is equal to MIPS nights execution time. So with this logic, the speedup can be equal to 12t times 1, because it is 100% of the execution time executed by MIPS nights, over new execution time, which would be equal to 30% of the execution time times t, which is the portion that's going to be executed by MIPS FP, plus 70% of the time times 12t, which is the execution rate for MIPS nights. This simplifies to 12t over 8.7t, which is equal to 1.379. This means that it is going to improve the execution time by 1.379 fold. Note that this can also be calculated as using this formula. With partial credit 2, I began by normalizing the time into the time of the unenhanced system's execution time. By dividing 1 by the improvement factor, this gave us the number 0.725. This means that the enhanced execution time is 72.5% of the unenhanced execution time. Further, we can multiply this by 0.3, and we do this because the MIPS FP chip processes 30% of the processing, and this gives us 0.2175, which means that 21.75% of the unenhanced system's execution time would be executed by MIPS FP. For partial credit 3, I started by setting up some fractions, which would be the improvement factor over the cost of the system. Solving for x, we get $41.37. And this is the cost of the whole system. So because of this, we need to subtract the cost of the MIPS nights chip, so we could get the cost of MIPS FP, which is $11.37. So this means that MIPS FP needs to be less than or equal to $11.37 in order for it to be worthwhile to buy. In other words, in order for it to provide a performance benefit per dollar.